Croteau. Hi Greg, hi Angie. We want to make a little video and show you how the equipment that you so generously bought us has impacted our recent cadre of students. This is Rob Dudik, this is Ryan Sakachi. And the cameraman is our lab manager, the intrepid Majid Mokhtari. Okay, so one of the sets of equipment you bought, this is for the electromagnetism lab. What we have here is we have a spectrum analyzer. We put stickers on it, we were so impressed we put little, and we have the computer to drive it. So we got little tags from it so everybody knows. Mainly this is an anti-theft device, so everybody knows leave this in the lab, but that's okay. We have the spectrum analyzer, and we have a thing called a tracking generator. What this guy does is, this guy sends a signal from 0 to 4.4 gigahertz, which is an amazing capability right there. And it sends it into the spectrum analyzer, and this cable synchronizes everything. So the spectrum analyzer knows that the tracking generator is sending a signal of a particular frequency. Then you put something in here. So we have them talking, we're going to normalize the curve. We'll take you around in a second and show you the curve. Then what we do is, we put a piece of equipment in here, and we see what frequencies are blocked by the piece of equipment. And actually, it's very important. These guys are electrical engineers. They're going to be designing network analyses, or they're going to be designing communication networks with microwaves, cables, stuff like that. So we're just going to show a very simple but super practical problem. What happens when you put a cable into a system? This is one example. We won't keep you too long, but I think you'll be impressed. Come around here now and we'll show you the software. Okay, Rob, will you go up to the utilities menu? This is the software. This shows us here the graph of what the signal generator is receiving. It doesn't really mean anything at the moment. Could you go to analysis mode? One pull down menu over. Good. Go down to scalar network analysis. Good man. Now, could you go down here to the 10 decibel level? That's grand. Make that 10, not 30. The reference level. Good. Just hit 1, 0 and enter. It'll know what to do. Good. Now look at this raggy line here. We need to normalize this because this is the signal generator, the tracking generator is sending all these frequencies and this is what's being received. So I want you to go to here and put this span to be 4.4 G. And then put the span here to be 2.2, the center to be 2.2.
Giga, right? G,
yeah. Yep. Perfect. Oh, that's a exclamation mark, I think. Oh no, that's okay, that's fine. Yeah. And now, just hit store true. And you'll see the line will go flat. Then that'll be our reference. Hit store true again and hopefully the line, mother of God, go flat. Damn, there you go. I was going to yell at the computer. Sometimes you have to yell at this equipment, even though it's very, it's the Marx Croteau family equipment. Sometimes you have to yell at it, and there's a message in that for you, Greg and Angie, coming down the line. When the cuteness wears off, a little bit of yelling might have to come into your recent acquisitions. Greg and Marx have a baby. Okay. So now here's what we're going to do. We're going to do something simple. We're going to add, Ryan, I want you to add this line into the system here. Okay. We're just making the connection longer. That's all we're doing. Now, if it doesn't make any difference, watch what happens to the flat line when he disconnects it. The flat line, it all goes down. We're getting nothing. There's only noise at the very bottom.
Let me connect this.
Connect that right up there. And now, do you see what happened? All we did was add a line. Mm-hmm. And Rob, what do you see here? Describe what you see.
The signal dipped down once we added the longer cable. And instead of being flat, we have some oscillation going on.
So there's certain frequencies that don't like to be transmitted through this network. Ryan, I want you to replace this with this.
Yep.
Now the craziness is about to happen. Not yet, but soon. There'll be craziness. It'll be worth it. Oh, mother of God. All we did, sorry, Rob, what do you see?
Yeah, all we did was add a T-junction in, and now as you can see, we had this huge dip here. The signal up here is still kind of the same, but we had a huge dip come down once we added just a T-junction.
Well, can you tell us what can you put the cursor on that dip and find out? Okay, so 3.3 gigahertz. Well, supposing I wanted to communicate with a 3.3 gigahertz signal, and I randomly put this in to my cables to join something up, what would happen?
You'd be transmitting to that signal.
You'd be killing the signal. Nothing would go through anymore.
Right.
Okay, that's fine. But 3.3 gigahertz is really high. Let's go down to let's leave it. Let's just put in. We said that you can filter with a cable. I want you to join this cable to there. This is just an ordinary cable. Let's see what happens when you stick it in. We've got a comb. What do you see here, Rob?
Let's see. It seems like the signal is being filtered by the cable we just put in, because that really low dip that we had is gone now, it seems.
And now there's certain frequencies that simply don't get through.
So it's being filtered.
And that's strange. If we were to measure this cable and look at it, we worked through, remember those equations we worked through in class for the quarter wave? Remember we said there's a transmission line that's a quarter wave line?
Yep.
Well, depending on what the frequency is, you've got a quarter wave line. Look at this. This is a different length line. It's got a different capacitance and inductance and stuff like that. And look, it's completely killing signals here and here.
Yep.
So there's a comb of them. So this is the kind of thing you have to take into consideration. Okay, guys, everybody say thanks to Mr. Croteau and Greg and Angie.
No, thank you.
Thanks.
And this is one of the things we learned. There's many more things we can do. The guys here made antennas. They made radio antennas, and we can test radio antennas with this to find out, do we have good antennas? What are the properties of our antennas? Okay, this is just one of the things that we did. Thanks very much. Okay, bye.